Welcome everyone to Simplifying Real-Time ML Pipelines. Although I should really have called this the most dangerous demo ever, or how to have a heart attack on a stage, because you know what they say about live demos, they always go wrong. And this is basically a huge succession of live demos that we're going to be building together today. I am Javier Blanco. I am Senior Data Scientist at Quix. We focus on data streaming. So my areas of interest are in real-time, causality, and well, just in general, keeping data science as simple as possible. And just as Chet was saying, today's presentation is supposed to be more of a session than a presentation. So if you just want to watch, that's fine, but this session is really designed for you to be active, to interact with it via the polls that I'm going to be sharing, typing in the chat, or even running some code that I'll be sharing as well. So if you're following this from a desk and a proper screen from your PC, I think you'll have the best experience. Otherwise, don't worry, it'll be fine as well. And a way to be interactive in this session is to actually download this Quix tracker app. By downloading that, it will be producing telemetry data that I'll be able to analyze in real time. So all of you Android users, this is an Android-only app. All of you Android users, go to Google Play and download Quix tracker. And let's set up the objective of this session. This little use case, this little project that we are going to build, came to our company by one of our customers. So they have fleets of bikes in different cities, shared bikes, and they wanted to detect any potential crash, any user having crashed the bike. Obviously, this is an event that you will want to react to in real time to offer help via the app or maybe checking the mechanical state of the bike. So how do we create an architecture like this? One that is feeding real-time data from the customer apps, then using some machine learning model to detect the event of a crash, and then reporting back again in real time to the user app, the company headquarters, or whatever is needed, the information, the alert of that of that crash. This is what we will solve today. We will solve how to create real-time systems like this when we use machine learning. And to work with real-time data, we are going to be working with streaming technologies. So just as Chet said, I've led a poll in the Slack channel, so you can answer. The idea is that you tell me whether you have or not previous experience with streaming technologies. I'm going to put it in the chat as well. So if you're following this from the app, you can just type yes, a bit, or no, depending on your experience in this area. By the way, the session doesn't expect you to have any previous experience, so don't be shy about it. We are gonna assume no previous knowledge and explain streaming from scratch. Looking at the poll results, I see most of the people have responded with a bit or a straight no, which means, again, yeah, most of the audience doesn't have previous experience with streaming, and that's fine. So I'm going to go straight away and tell you what streaming is. And to tell you so, we are going to compare it with the more traditional, more typical batch approach. So let's go back to that use case that we were referring to. And let's think of a user just pedaling their bike. And their phone will produce a point of data at some point, right? And life will keep going on. That bike will keep rolling, and at some point, it will produce another point of data. The user keeps using the bike, And again, after a certain time, the bike sends some of that telemetry data to that database, and that point gets persisted there. And you see where I'm going. If we generalize this, the bike is rolling over a bit of time and then producing data every certain period. Now, with the batch approach, we will query that database periodically. Let's say it's every 1 hour, every 1 day, every 10 minutes, whatever the period is, we will wait to get some data persisted in the database, and then we will consume that data. We will load that data from the database in our analyzing system. And this processing system, this analyzing system could be your Jupyter notebooks, could be your SageMaker, could be any script that you have in production. The key is that this is some code that is going to perform some transformations on that data. And as you saw, we waited for a bit until we had a batch of data there, and then we loaded it. And that's a table, right? And you see 1 row per every point of data that had been produced. So we have T1 for that first point, T2, T3, and so far. And with a table like that, we can do operations, and this is the way we are used to do it. Like, I could calculate total G forces as the sum of the absolute sum of the x-axis forces, y-axis forces, and z-axis forces, for instance. Or we could do operations that require information from other rows. Like here, we are doing the delta total G forces by doing current G forces minus the previous one, right? Nothing new in here. This is the way we are used to work, and this is batch. There's nothing wrong with batch, apart from that we have had to wait until Tn here to actually process the information in T1. So if we were waiting for an hour before processing the data, we're actually processing data from 1 hour ago right now. So we are inserting some delay, and in some cases, that is actually problematic. And even when it's not, just the value of data decreases over the time that it takes us to act on it, right? So the sooner we act on it, the better. With batch, we are just losing some time there. And we are also spending some resources here in persisting data in a database, then loading it to somewhere else. Good, so this is batch. This is what we know. Let's see how streaming looks like. In a streaming world, the bike will produce data points just as it was doing in the batch world. But instead of being database-centric, the streaming world is a streaming broker-centric. Like, this is a streaming broker, like a Kafka topic, to be specific on one technology. And this producer entity has published some new point of data in there. Now, our processing system is subscribed to that topic. So the very moment that topic gets that new point of data, so it does our processing system. So you see, we have now information from T1, and that means we can process that information right now. We can do that calculation right now without having to wait longer. However, there are also complications with streaming. And some of those are that when you require some historic data, things get a bit harder. So for now, I'm going to keep in memory, we are going to call that the state. We're going to keep in memory the total accelerations information right now at T1, because we are going to need it later. Now the deltas is too soon to calculate, so let's wait until the next point of data is produced. So the bike is going to keep rolling. Now it has produced a new point, and immediately we have that data available in our processing system to process it. We can calculate the total Gs, that's easy. But now you see how having saved in memory the previous total Gs information is coming very handy to calculate the delta. And again, this is the thing with streaming operations. When we need historic data, we are going to have to handle what we need to keep in memory. So right now, I'm going to have to update that state to be ready for the next operation. I'm going to upload it with T2 information. And now we are ready to wait for T3. We will be, once that new point of data is produced, we will be able to process that data straight away. And just to generalize it, so you see where we are going. There we have our TN point with the information that we have to keep in the state at that point. So what are the advantages of streaming? Well, it's real time. As soon as the data is produced, we react on it. And that's very, very important in many use cases. However, it can be harder. It can be harder to make operations like we have just shown. We have to keep an eye on what we want to keep on the state in memory. Good. If you have any questions about streaming, keep asking in the chat. My colleague Steve or I will answer them. Now, let's look at how a typical architecture in this use case will look like, both in batch and streaming. This is a AWS example, but it helps us get the point. And what you see is that in batch, everything is database centric. So you see those C3 buckets there. Well, let's see how this will work. First, our customers riding those bikes will be producing data with their phone apps. So that will send the data via API gateways through a Kinesis system and basically dump it in a database in that S3 bucket. Once it's here, we can do things. We can, for instance, train a machine learning model to detect those crashes. Once that ML model artifact is ready, we can save it in another S3 bucket. But also, we will create some orchestration here to react, as we were saying earlier, maybe every hour. So we will do that here, and this crash detection server will be using the train model artifact and the latest information in that S3 bucket to produce alerts over the last hour. Those alerts, by the way, where do they go? Yes, to another S3 bucket, to another database. So you see my point. Batch architecture is database centric. Sometimes that's totally fine. When we need real-time actions or results, we may want something different, something like streaming. In streaming, the journey starts the same way, but then those points of data are published into a topic. And now, the fact that we are sending them to a topic doesn't mean that we don't have to store them or that we don't want to. Some data may be useful, but we don't dump the data into a database. We synchronize a topic to a database. So data keeps flowing, the data journey keeps going, and synchronized to that, we create a database. That is what we are doing here. And with that database, we can create a machine learning model as we did earlier with SageMaker, just the same, or with your Jupyter Notebook, whatever technology. And now that ML artifact can be consumed from a service. This service is subscribed to that topic in real time. So data comes by in real time. Predictions are done in real time. As soon as a new point of data is received, a new prediction is created. So this alert topic is working as well in real time. That means that anything subscribed to this will be able to see information around whether there has been a crash, and it will do in milliseconds from the moment the crash is started. That's how two different architectures work, batch versus streaming. I'm very enthusiastic about streaming because that's what we are trying at Quix. We are trying to make a streaming, which is very powerful, but also has traditionally been being a bit complicated, we are trying to make it as simple as possible. And our founders, they really needed to make streaming as simple as possible in their previous role. So they used to be McLaren Formula One engineers. So that has to be one of the most rapid data environments that it exists. Imagine Formula One racing cars producing telemetry data at a huge frequency rate from hundreds of sensors each car. And that data had to be analyzed in real time. And they realized how the technologies that allows these amazing performance like Kafka and streaming in general are really hard to use to the people that have to do those analyses, like data scientists, data analysts, etc. So at Quix, we are trying to make streaming easier. And there are two main ways we try to do that. One is with a software as a service platform that helps you manage your Kafka topics, put code into production, use Kubernetes, serverless operations, use code templates. There are many things in there making your life easier, helping a team work together in different languages. But this is not my focus today. Today, I want to tell you about Quix Streams. Quix Streams is our Python library to working with Python, use streaming at its maximum. And we have very recent news, just like 10 days ago, 11 days ago, we went open source. We are very excited about this. We want to build a great community and create this library that doesn't exist yet, that will allow people to use real-time, be empowered with real-time results without having to learn Kafka. So Quix Streams, it focuses on time series data, and we try to make it as simple to use as possible. You can use a broker as Kafka or another one, and use that instead of a database, so that you process time series data with performance, with low resources, and without delay. And that's all the introduction, all the slides, pretty much all the slides that I have for today. Let's now get on with it and start building some demo. Just before that, I have to tell you about one more thing around streaming. So there are three main first citizens in streaming. One is the topic, the Kafka topic, or more generally, the streaming broker. This is the infrastructure where data is streamed. So this is where we will be interchanging data. The other two are the publishing party, that is the producer, and the consumer. So producers are parties publishing data into the topic. In some seconds from now, you're going to be a producer sending some data to a topic. You'll see. Subscribers are doing the opposite, that are consuming the data at the other side of the topic, so that as soon as producers publish it to it, they consume it and they have it available. Yeah? Good. Let's start the demo. I'm going to open a chat room in a moment. That is an app. And there are two topics that we have to care about. One topic is called chat messages. This is where we are going to be publishing the messages to that the chat room reads. And the chat room also has a text box where we insert our messages. So it does both things. It consumes data from the chat messages, but it can also publish messages to it, right? So when you write a message on your typing box, you will be producing a message to this topic, and then all the messages are shown in another box that is consuming data from that topic. That is how it works. And then there are some aspects of the UI that are empowered by parameters that you you will find in these other chat messages enriched topic. So I'm gonna open the chat. There we are. And I'm gonna ask you to use your QR readers in your phone and join me there. So, hi everyone. And in the meantime, I'm gonna share a link because I'm gonna be giving you two ways to send data to this chat. One is via the phone, as some of you may be doing right now. The other is with a little notebook in Colab, so that you can see how Quix Streams works. I'll be showing you how to do that in a second. So I can read Steve there, very nice. So what are we doing there? We are basically using your phones as producers to this topic, right? So all of you connecting with your phones will be a producer publishing data to that topic. Another way, hi, we have AMR there. Another way to publish data to the topic, as I was saying, is with code. So I'm going to show you, by showing you this piece of code, I'm going to show you how the Quix Streams library works. So this is Colab. For any data scientists in the room, you probably know about this. And as you see, I'm going to be executing cells. This is just my IDE of choice for today. And I'm going to execute import pandas. I'm going to import Quix Streams as well. This is the open source library that I'm so enthusiastic about. And this is all I have to do to send a message into a topic. I will first create a client. This is going to be talking with the Kafka topics for me. I just need some permissions to do that. And now I'm going to create a producer entity. So just as I was insisting, there are two main types of entities: producers, send, publish data into a topic, and consumers that subscribe to data in the topic. So I'm initiating a producer that is going to be publishing data to that topic, their chat messages. And then I define the stream that I want to produce that data to within that topic. And I'm going to explain what a stream is in some minutes. But for now, let's just assume we send the message there. And now, this is the message that I will be sending. You see, it has a timestamp and it has a message that I want to be shown. So I'm going to use my name. And I leave that message as it is. Nice. That is a nice, simple data frame. And here, I'm sending it to the chat. And there it is immediately. So that's how you publish data into a topic with Quix Streams. You have the link in the chat. You can give it a go on Colab if you want. Or you can try to use your phones and your QR readers, just as I'm doing here. Good. Thank you, Steve. Yeah, I know there's 20 seconds lag. That's totally fine. You can catch up in 20 seconds, of course. So we've covered how to publish data into a topic. We have just done that. That's what we're doing here, really. We are publishing data to that chat messages topic, both from Colab and from the phones. That's what we are doing. We are going to see now how to subscribe to data into that topic. For that, I'm going to be using Colab. So I'm going to open my Colab. In the notebook before, we were showing how to publish data into a topic. Now we're going to see how to listen to data into a topic, not just publish into one. So for that, I'm going to need the topic consumer entity. So as you see here, I'm creating a consumer entity that is listening to that chat messages topic we've been talking about. And I'm also creating a topic producer entity, but this time I'm going to be producing those messages to that other topic, the chat messages enrich, that other topic there. So I have just created those entities, and I'll show you how to listen to data. So what we do is that consumer entity we had created, we use this on stream receive callback, and that means we'll be listening to any new stream coming in. And what do we do when there is a new stream coming in? Well, whatever we define in this function. Here in this function, what we are saying is whenever there is a new data point, we do this. And what is this? Well, whatever we define in here. And you see what I'm defining here. Well, I'm going to simplify this actually, and it's going to be a simple print. So I'm just going to be printing any new data coming in. Yeah, I'm running this. So I'm going to be typing something here. And it will arrive here unless I've done something wrong. So I'm not seeing it here. Well, these are the live demo issues that I can experience, but that's fine. That's totally fine. I'm gonna keep going, and I'm gonna use transformers. That is the Hugging Face library, the open source Hugging Face library, to do sentiment analysis. So I'm gonna install Hugging Face, and then I'm going to import the module pipeline from transformers. So for those of you who don't know Hugging Face is a nice open source initiative that is publishing to the public, let's say, state-of-the-art deep learning models, both the actual deep learning artifact already trained, and also the data sets that are used to train those models. So if I come here to models, you will see I can choose from computer vision to natural language, audio. We have many very powerful models trained by very powerful entities that have access to big sets of data. And we also get some of those benchmark databases. So this is a good place to come for some of these natural language processing models. And that's what we've done here. And now that we've installed that library, I'm gonna download a specific model. This is just their benchmark sentiment analysis model, and the one that I'll be using to analyze messages. So the idea is that that pipeline model that I'm downloading, when I pass it a text like everyone, hope your day is great. When I execute this, the model will give me the sentiment analysis. So it has two levels, positive and negative. There we are, this is positive, and score, which is basically a likelihood of that label. And we can pass several messages at once, like now I'm passing a list. And you see, it just analyzes both messages. If we wanted to get this into a data frame, I could do just this. And this is exactly this line of code that I have just produced is what we will be using within our processing function. So let's create that processing function. You see here, I have that topic consumer listening to streams. And basically within here, we define how we process the data, any new point of data we've received. So I'm saying, I'm using the model, just as we did here in that line, to predict on the messages that we have just received. And then I'm adding those new columns, label and score, to the data frame, the original message I received. And then this is just pandas, right? This is a typical batch transformation, even when we are going to be doing a streaming. So I'm adding a new column called sentiment. I initialize it as equal to the score. And then I create a filter so that when the label is negative, we actually change the sign of sentiment. So there you see a minus there. If I run this processing function now and type some messages, we should see how this processing function is enriching the messages and sending that enriched message out to the output topic. So I'm going to say, hi, hope everything is good. And there you see that message adding score and sentiment. So we are processing it in real time. By the way, you see that the UI has used those new parameters to put a happy face on my comment. If I say something sad, the opposite will happen. Once it is analyzed, I get my sad face there. You can test this. I know there's a 20 seconds delay, but if you send a message now, it will be analyzed with this code that I'm running here. That is the beauty. You all producers can send messages, and this consumer is going to be receiving messages from you all. So I'm going to keep saying positive and bad things to give you time to add something new. Okay, thank you, Steve. Yeah, it seems to be working. Perfect. So that's how streaming works for processing purposes. You see, we are listening to recap for the last time. We are all publishing data to those topics, either from Colab or your phones. And then the chat room app is consuming those so that we see them. But also we are using a Colab to subscribe to that topic. So both the Colab and the chat room are consuming the messages in that chat message topic. And this is one of the main points of streaming architectures. They escalate very well. You can have as many producers and consumers as you want. Now, let's end up, because we have 10 minutes left, let's end up with the use case we started with. How could we detect a crash? How could we use streaming, as I've just shown you, to detect a crash? Again, I'm going to ask the Android users to open their Quix Tracker app. And for those of you who downloaded it, these are the instructions to set it up. You click the 3 lines to access to the menu, and then you are going to scan the QR code. There is some delay, so I'll keep explaining the instructions, and then I'm going to be showing the QR code. So hopefully by the time I show the QR code, you already know what the QR code is. The QR code is gonna fill some of those fields for you, like the token and so on. So as soon as you see me showing the QR code, you will click scan QR code. And then once you do that, there's some more fields you have to fill. There is the topic field. It has to say phone data as phone dash data. And then in right there, you will just use your name, okay? Or any alias. So I'm gonna show the QR reader now. I'll do it this way. So I'm gonna produce that QR reader. Great. Now, use that QR reader, and I'm gonna connect to the app as well. And once you have completed all the parameter setting, you can go back to dashboards and click start. And that will generate data into a topic. I'll show you that in a second. So I'm ahead of you 20 seconds or so, but you see that phone data is receiving some data, right? That phone data topic, you see how it's receiving some bytes of data. If I go there and see what type of data it is receiving, good. You see, great. You see my phone is there. Some of your phone or of your phones are there, but you didn't set up the name. That's fine. So we cannot distinguish right now who of your phones that is, but that's totally fine. So we are receiving data from my phone and your phones into a single topic. And I'm gonna show you now how we could run a machine learning model on this data. The code is very similar to the code that I have just shown in Colab. Only this time, its main purpose is to generate predictions. So you see here, we are loading a machine learning model. This is a pickle file that we are bringing from blob storage. And then, just as we were doing earlier, we define the topic consumer entity and we react to it. And this is the important bit. This is where we are reacting to new data. By the way, how does this data that we are sending with our phones look like? I can just click there and have a look. And you see that we are receiving G-forces in X, G-forces in Y, G-forces in Z. Good. So my code, it first ensures that we have G-force in that DF we have just received. If so, it will create a new column called G-force total. And you see it's the sum of those. Then it will create a new column called shaking. And that is a prediction from that model we have loaded. We send the feature variables and the model returns 1 or 0, whether it is shaking or not. If it's shaking, I'm gonna print into the console that whatever phone is being shaken. And I'm gonna send a message to the output topic, but only if it's shaking. Good. I have this in production, so I'm just gonna click start, but this is the very same example I was showing. So these are my logs, and I'm gonna show you at the count of 3 to start shaking your phones like crazy. Let's see if we see them here. It's a 30-second delay, so I'm starting now. Hopefully, we will see your messages too at some point. Good. So let's see what we are receiving. Good. Those are your phones. my phone. And you see we are producing some output data now. You could see there. So I'm gonna keep shaking. There we are. Those are some phones being shaked. Thank you very much for helping in the demo. So whoever is shaking their phones, you see how they are producing alerts here in this output topic. So there we see the alert, phone shaking by your name. And we can see that in the logs as well. I've been shaking my phone, so have you. And that's it from me today. Oh, you see Steve data coming in now. And hopefully you see how these machine learning models can escalate much better in a streaming system like this. I want to finish with a thought. Imagine this shaking or crash detection use case with batch. It will just wouldn't be possible to do this fast as this scale. And this is what we are trying to promote at Quix with this open source initiative. We want the world to go real time with us. So if you want to help us in this initiative, we are making this library for the Python community for you. So we will really appreciate if you go and check Quix Streams and contribute to the open source project. The quickest and easiest way that you can do it right now is to use your QR scan reader for a last time. Go to the GitHub profile and give us a star. So thank you very much. This has been our talk. I hope you have enjoyed it. And I just want to finish by saying that we have a competition running. If you want to check the details, it's on the hallway. Without draws, we are giving $50 Amazon vouchers away if you are able to do a certain technical challenge. So let's see if you are up for it. Have a nice day. Bye-bye.